Hello everyone. Today we'll be solving a structural mechanics problem. I am reading out the problem. A step bar is subjected to axial compressive forces. The diameter of the bar are 15 mm and 10 mm, and we have to determine the nodal displacements at 2 points. The Young's modulus and the Poisson ratio of the bar material are 2 into 10 to the power 5 Newton per mm square and 0.3 respectively. So for the designing part we'll be using SolidWorks, and for the simulation part we'll be using ANSYS static structural. So this is the SolidWorks interface, and now we'll select the front plane and go for sketching. Let us click this circle and draw a circle. Now we'll set the dimension using smart dimension feature. We'll set the dimension to 0.015 meter. Okay, and now we'll extrude this. The extruded length will be 180 mm or 0.180 meter. Now we'll click OK. Now since we need to draw another step rod, so we'll click sketch and draw another circle here so that we can extrude that circle. So this is the second circle. We'll click OK, and then we'll set the dimension for this in the same way. The dimension for this is 0.010 meter or 10 mm. Now we'll click OK, and then we'll extrude this circle like we have done in the previous case. So for this, extruded length will be 200 mm or 0.2 meter. We'll click OK. So this is the total design of our step rod. Now we'll save this. We'll save this as problem 7, and the extension will be IGES, as we have to import this in ANSYS. Now we'll go to the ANSYS workbench and select the static structural. Here we'll import the geometry that we have already made in the SolidWorks. So desktop. This is our geometry, and we'll open it. Now we'll update this model. It will take some time. Okay, now so update is done, and now we'll edit the model. Okay, so this is the geometry that we have imported from the SolidWorks, and this is the interface of the ANSYS structural mechanical. So here we will set the where the forces will be applied and which side will be the fixed end. So for this setup, we'll go to insert and then select and click fix support. Now we have to select the face which will act as the fixed support. For that, we'll click this N and then apply. So this face has been selected as the fixed support face. In the same way, we'll select the four faces where forces will be applied. So in this end, the force applied is 2 kilonewton. So we'll specify the force as 2000 newton or 2 kilonewton, and then the direction of the force is compressive, but here we can say this tensile. So we'll change the direction to compressive and then apply. Now in the same way, we have to apply a force in the step part. So we click here, insert, and then force, and then we zoom in, and then let us apply force here. So we apply, and then the force here is 5 kilonewton or 5000 newton. We click enter, and here in this surface too, the force applied is compressive force. So we'll change the direction to compressive and then click apply. So this is done, application of forces, and the setting up of the fixed part is done. Now we'll go to mesh. We'll first generate a normal mesh which has been already generated. Now let us go for refinement. We'll select the not refinement. We'll go to sizing. Here we'll select the entire geometry and then define the element size as 0.002 meter, and then click generate. So now the mesh has been generated. Now we'll go to the solution part. So here, since we are required to find the nodal displacements at 2 points, one of the point is in this end and the other point is in this end. So we'll go for insert and then deformation. We'll go to total deformation. Instead of all bodies, we'll select the face. We'll select this face as we want the deformation at this face and click apply. We'll click another deformation face for this surface. Instead of all bodies, we'll select this surface and click apply. Now for just our information, we'll select the entire geometry and find the total deformation. Click apply. Now since we are also required to find the nodal displacement at points B and C, so let us go to deformation and directional deformation. We'll select the face. And this direction has to be along the x-axis, which is already there. So again, for the another surface we'll do the same thing. Also the orientation is x-axis, which is required. So this is our setup. Now we'll solve the problem by just clicking this solve button. Okay, so solution is done. Now this is the total deformation at this surface. So we'll do the animation. So here we'll zoom in so that it's properly visible. So this is the animation for the total deformation. Total deformation at this end. So for the other surface, this is the total deformation in static way, and this is the animation. This is the total deformation of the entire structure. So you can see the deformation with compressive loads being applied at the two surfaces. So now we see the directional deformation at this surface. So this is the simulation for directional deformation, which means it shows the deformation only along the x-axis at this face. So we zoom in. Now for the other surface, go to directional deformation 2, and then so this is the static view, and once we play the simulation, it will look somewhat like this. This is the directional deformation at this surface. So once again we go to the total deformation. So this is the total deformation, and this is how we have solved the problem given to us for the end semester examination. Thank you.